Hello friends, welcome back to my channel Ray the Chemist. Today on our show Rocket Monday, we're gonna talk about how satellites work and all about satellites in general. Today is going to be a very fun session, so let's get into it. So first question arises that what is a satellite? A satellite is basically any object that moves around a planet or even a celestial body. So right here you can see some images of satellites. These are basically satellites which are orbiting the earth right now. Okay, so let me just give a brief introduction on what orbit means. Orbit means that, for example, this green body is our earth and this body is the satellite. So what the satellite will do, it will revolve around the earth in a fixed elliptical orbit. Now, this elliptical orbit is the path on which the satellite moves. This is always fixed. Okay, so it may fall down over time because of the drag if it is not up high in the atmosphere in actually sky sky. If it is not high up in the sky, there will be a bit more drag which will cause it to come down. So that is why we need reboosting of these satellites also. So basically any object that moves around a celestial body like a planet in a fixed elliptical orbit is known as a satellite. So now satellites can basically be of two kinds. One is the natural satellite, obviously created by nature, and the other is artificial satellites. We as humans put these artificial satellites into orbits using a satellite launch vehicle, and we'll be discussing about the satellite launch vehicle in just a few minutes. So, before that, let's take an example of a natural satellite. One very good example is the moon. The moon. So, if you take the Earth's moon, this is a natural satellite of Earth simply because the moon is always rotating around the Earth. An artificial satellite could be the Sputnik satellite. Now, the Sputnik satellite was the first satellite which was put into orbit by Russia, and also the new Russian COVID-19 vaccine is also named Sputnik 5. So that's where the name Sputnik 5 comes from, the first Russian satellite or the first satellite in the world which was put into orbit. So this is basically what a satellite is. The first satellite was Sputnik, and now let's move on to that how is it put into orbit. Now there can be many ways in which a satellite is put into orbit. The main way or the most commonly used way is a two-step process where a satellite launch vehicle, which could either be a spaceship, a space shuttle, or either it could be a big rocket like this Atlas 5 right here. So this satellite launch vehicle gets the satellite up into space at a perfect altitude where the drag is not as high to make it always fall down, and also so that it stays in orbit, and then it launches it at a specific velocity where it starts rotating or spinning around the earth without any requirement of some propulsion. Okay, so this is basically what the job of a satellite launch vehicle is. So it is basically a two-step process where first of all the satellite launch vehicle, which could either be a rocket or the space shuttle, it takes this satellite, gets it high enough so that there is as less drag as possible, and then throws it at a velocity high enough to make it spin around the earth. Now, talking about the parts of a satellite. A satellite is basically a combination of three or many systems. Main three are these ones. These main three systems are the communication systems, power system, and propulsion systems. Now let's talk about each of them in detail. Communication system basically allows the communication from the satellite to the earth and from the earth to the satellite. Whenever communication is done from the earth to the satellite, so if this is the ground stations on Earth. These are the ground stations on Earth which have large, big antennas like this. These are known as ground stations or earth stations. These basically communicate with the satellite that is up into the space. So the satellite also relays some information down to the earth, and also earth ground stations send commands to the satellite. Whenever commands are sent from the earth to the satellite, it is known as a uplink. It is known as a uplink, and the and the antenna or the ground station which is having the job to do this uplink connection, these are known as the uplink ground stations. But whenever the satellite has to relay some information back to earth, it uses a downlink, and this data is captured by a downlink satellite, sorry, downlink ground station. So basically this is about the connection or the downlink and uplink. What are the parts that are installed in this uh, satellite which allow for it to communicate? These are basically antennas which basically collect the signal that either is sent from the earth or throw the signal down to earth, and transponders are the ones which make sense of this. This signal is first captured by the antenna, then moved to the transponder the where the where this data is made sense of. Next system that I'm going to talk about is the power system. Now obviously everything requires power for functioning, and also the satellite. So for the power, the satellite basically relies on mostly solar power or the power of the sun. So solar cells are installed on these satellites which collect the energy from the sun and then give it back to the systems inside the satellite. Now, in most cases, solar cell is enough. But when you have to go beyond like Mars and Earth, the 100 kilowatt panel, that is 100 kilowatt solar energy panel, which is outputting this much energy on Earth, only outputs around 60 to 65% of what it outputs on Earth. This is in conditions of Mars and this is in conditions of Earth. So this means that there is a very drastic decrease in the amount of energy that a solar panel outputs in space. Now this is because of the inverse square law that is followed by optics or light. So to overcome this power loss, there is also another alternative which is basically using nuclear power. Now here you see a piece of Pu-238, plutonium 238. Now it is a radioisotope of plutonium, and this, whenever decays, it releases a large amount of heat. These things which you see right here, these are surrounded by thermoelectric generators, which are basically ceramic plates which convert this heat energy into electrical energy. This is what is about the power system. There are two basic ways in which power can be provided to the satellite. Those are using a solar cell, and next is using a nuclear power. Now let's talk about the propulsion system. Now propulsion system is basically a mini rocket that is installed in the satellite. These are very much useful whenever we have to reboost the satellite. As I told you in the starting only, the satellite sometimes has to face issues with drag, due to which its speed slows down and it comes down. It slowly starts to come down. Now, this is a very big problem because we do not want the satellite falling on somebody's head. So it has propulsion systems which are basically mini rockets. These are generally propelled by liquid engines because they also need to be shut down whenever the satellite has reboosted enough, and also need to be able to restart again and again. Sometimes ion engines are also used. So this is basically about the main three systems of a satellite. Now talking about the third one, this is basically all the sensors that are included in a satellite. So the sensor system is basically consisted of many different types of sensors. Now what sensor a satellite contains is completely dependent on what is the purpose of the satellite. We'll be discussing about different types of satellites in just a few minutes. Before that, let's talk about some names of different sensors that are generally included in the satellites. Those are altimeters. Altimeter is basically telling you the distance from Earth. So if you take the altimeter of a plane, let's say, it measures the distance from the sea level. If this blue line represents our sea level and this purple spot represents our plane, the distance between these two spots is told to us by an altimeter. Altimeter basically is also relying on the air pressure. So the difference in air pressure tells us about the of a height of a particular object. Next is barometer. Now as I told you, the altimeter relies on the pressure. It takes a note of the pressure of the surrounding atmosphere and then gives us the accurate altitude. Now what what finds the pressure then? Barometer is responsible for finding the pressure. So if you, let's say, go into a vacuum chamber, you will get zero zero pressure because there is an absence of air. Now barometers pressure are generally measured in millimeters of mercury. Now mm is millimeter, hg is for hydrogenum. Hydrogenum means mercury. So millimeters of hydrogenum or mercury is the unit for representation of pressure. Next is thermometer. Thermometers are very important because they tell us the temperature of a particular place. Now temperature also is a factor for many different things like crop growth and other stuff, which is also a part of the satellite. Now we have got enough about the parts of a satellite. Now moving on to the different types of a satellite. So there are multitude of number of satellites that are available right now at the market, but talking about the major or the most important ones, those are the communication, remote sensing and miniaturized satellites. Let's talk about them in detail. So if you talk about a communication satellite basically allows you to relay data from one place on the earth to the another place. Now, let's see how does it happen. You have basically two places here. Let's say these two are your TVs on earth. Your dish TVs actually work with these satellites only. So that is a very interesting fact. The signal or the show that is being broadcasted on your TV is basically coming from space. So that is very interesting. So these TVs are basically taking the data that is relayed from a satellite. So you have a satellite right here which is relaying data to these number of TVs on earth. Where from it is getting its data? It is getting its data from a broadcasting center where the data is being broadcasted using large antennas, and it throws the signal up into the satellite from which it is then distributed to different parts of the world. So this is basically how a communication satellite works. It takes data from a broadcasting station and then puts it to your TVs and other things. Now let's talk about the next type of satellite, which is a remote sensing satellite. Now remote sensing satellite is a satellite which observes the earth with different kinds of cameras. Now there are many ways in which the remote sensing satellites can observe the earth. It is not necessary that they use a camera. They can also use uh, infra some methods in which they are picking up the heat signature of the earth. They can also actually observe different cosmic features of the space, outer planets, exoplanets. Many things can be observed with the help of these remote sensing satellites. Now, very interesting use of these satellites is the electromagnetic spectrum. They can have cameras which basically, let's say, detect infrared radiations or infrared light, and this can basically tell us about the global warming. Places that show high amounts of infrared light, which means that there is high amount of heat there, which means there is global warming there. So this is also a very important tool in weather analysis. How weather analysis can be done? Again, by using talking about the we can talk about the clouds that are moving on the earth's surface. We can also observe cyclones from these satellites up into space. Next, let's talk about miniaturized satellites. We have done remote sensing, communication, and miniature satellites is basically the new trend going on in the space industry. So, miniaturized satellites are CubeSats, Femto satellites, and there are also many other classifications of these miniaturized satellites. Now, most satellites are hundreds and hundreds of ton large, but these miniaturized satellites are very small, and they basically are experimental satellites. So, if you are experimenting, let's say, a new kind of small propulsion system, so you can put that into a CubeSat or a CubeSat and then launch it into space. These are very cheap to launch. They are launched on generally sounding rockets which are having a ballistic trajectory, which means they start from one point in the earth, actually like this. They start from one point in the earth and go up into space, come down, land in oceans where the payload or the CubeSat can be retrieved. Now, there are also many competitions which are organized for students of university and high school, where they create their own experiments which are fitted into these femto satellites or cube satellites. Like you can see right here, this is a CubeSat which is full of many science experiments that can be conducted in near space conditions. So that was it for today's video. Please like if you enjoyed this video. Please share also if you want people to view this kind of content, and subscribe. Also click the bell icon so that you get notified whenever I post a new video. I always post videos on Friday relating to Science Friday and on Monday relating to this topic which you see here, Rocket Monday. Thank you.